Okay. So see what's today's problem. Today's problem is given an array of integers, determine whether it contains a Pythagorean triplet. Recall that a Pythagorean triplet ABC is defined by the equation that a square plus b square is equal to c square. Okay, so we're given a list. We should just determine whether it contains a Pythagorean triplet. Fine. So we don't need to return which of them are Pythagorean. We just need to return true or false that it contains, right? So which means that so let's say that we have been given a list. Let's start with a list where we have 1, 5, 3, 6, 9, 4, right? If we have this list, it's a random numbers, but right, we know like by formula like 3, 4 and 5 form a Pythagorean triplet, right? 3 square plus 4 square is equal to 5 square, right? Since 9 plus 16 is 25. Okay, so we need to return true for this. This should return true. Okay, so how would we go about doing that? So one approach is we choose like one, like we'll choose one is one fixed value in this Pythagorean triplet, check it with every other combination 5, 3, 6, 9 and 4 and see if it creates a Pythagorean triplet for each one of the values. This would happen n times. Then second we'll take 5 as the in the second position, right? Like we can start with 1, have 5 fixed and check all the remaining values, right? Like we can check 3, 6, 9 and 4. So there are n options for that also. Or in the third position for 1, 5 and 3, right? 3 can change like 3, 6, 9 or 4. So we could keep checking like that. Or right, we could keep one position fixed and keep checking the others. Or okay, second approach could be that so this would be approach 1. How else do we do that, like without going brute force checking everything? Okay, let's assume that we store a list, right? We're going to store a list which contains Pythagorean triplets, like all of them are on squares only, right? So we could store the squares, like we'll store 1, 25, 9, 36, 81 and 16. Now after this, directly checking in each position might not make sense. If we were to sort this list, right, like if we have it like 1, 9, 16, 25, 36 and 81. If we were to have a list like this, let's bring this to the center. Yeah, if we have this as our starting list, from this finding out Pythagorean triplet might be a possibility, right? Like we can start let's say we start 3 variables. Okay, we can start at here. For position A, we need a Pythagorean triplet. Our intention is we need an A, B, C, right? Like A plus B should be equal to C, because I'm assuming A, B, C are squares, so C should be greater than A and B, right? In that case, if we say we start with A over here, C we can start from here because it should be greater, like, and B we can ideally choose it anywhere in between, or we can start it next to A only. or next to C. Any arbitrary position first till we find out a logic. Let's pick a position like next to C only, right? We'll say that this is B. So now we have A, B, C. After they have been sorted, first we check if A plus B equal to C, right? Here it becomes 1 plus 9. Is it equal to 81? No, it is not. It is actually lesser. If it is lesser, that means my A can increment, right? So I will move this A in the second iteration. This is first iteration. I will choose the color. Second iteration is, so I'm going to say A is over here. So I'm going to say 9. Sorry. In the first iteration, it was B was 36. Right, my bad. So it is 3 plus 36. 3 plus 36 is still lesser. I mean 1 plus 36 is 37. So it is less than 81. Second iteration, it becomes 9 plus 36. Right, 9 plus 36 is still less than 81. Okay. Let's minimize this, right? Right, so this is iteration 1. So now third iteration, we'll go with the third iteration where we are having in the third iteration what would happen is we would move A again to position 16. So this would be 16 plus 36, right, is less than 81. Yes, so we can again move A. So is a single pass going to be sufficient? Then we move A to 25. So this is 25 plus 36 is less than still 81, right? And now we try to move A again, but it is already at position B, like we would be stepping over B, and both we can't have same. So we stop here and say that one is no longer we have exhausted all of the possibilities. So 81 is no longer our option, right? If A became equal to B, right? If A is equal to B, when this case occurs, position of A is going to be, that means that C has to be decremented. Like we cannot consider 81, like we cannot form this 81. So C we have to do subtract it by 1, right? And then for this iteration, for the next iteration, let's minimize this, right? It's too small. Yeah, for this next iteration, how would be our new starting scenario? Our scenario will be something like we have an array where we have 1 9 16 25 36 and 81, right? Actually we can have it in the right side, that way we have more space for it, right? Cut it from here, paste it here. Okay, so now coming back to where we were, so we are in the right side now, right? We are here. We can minimize this and only concentrate on this. So now we have 81. Let's have 81 in the last. Let's go to 81. Right. Okay, rather we will recreate the list itself, that way it's much cleaner, right? Okay, we have a list now. We have a list where we have 1 9 25 36 25 36 81. I think there's a 16 also, right? 1 9 16 25 36 and yeah, 1 9 16 25 36 and 81, of which from the first iteration we realized that 81 is no longer a candidate for the Pythagorean triplet. C can now become 36, right? C will move one step to the left, B also would move one step to the left, right? And A would again start from position 1 to check whether it's a Pythagorean triplet. So now we would again follow the same procedure, I guess. Yeah, again step 1. So we will start with 1 plus 25. Is it equal to 36? Nope, it is less than 36. So I'm going to move 1a to the next step. In the next step it becomes 9 plus 25. Is it equal to 36? Nope, it is less than 36. So again a moves to the next step. Now it becomes 16 plus 25, right? 16 plus 25, is it equal to 36? Becomes 41, right? 16 plus 25 is 41. So it is greater than 36. If it is greater than 36, that means that A has come to a position where it is greater than that. In this case, moving A back one more step, right? Like we can't go ahead because it will obviously be greater. We have to go left. What should go left? If A can't go, C is already fixed. B, we can move B, right? So when A plus B is greater than C, in that case we go B one step. So we're going to move B now. So if you're going to move B, B will go from 25 to one more step. B will go to 16 now. A is also at 16. So it will say, hey, no, there is no space to go. Like B cannot decrement since A is already at that position, right? So it means there is no other possibility. Like we can't get when A equal to B position should not, that means that we have exhausted the possibilities of getting 36. So you can't get 36 in this case, correct? So second iteration also we did not get the answer. So this whole block is now going to get we can't use that anymore. Now we need to go to the next step. We are going to decrement C and check. So now what we are going to do is we are going to pick up next iteration 1, 9, 16, 25, 36 and 81, of which we already have satisfied the equation for 81 is not a possibility, 36 we can't form, right? In those two loops. So now C is pointing to 25, B is pointing to 16, correct? And A is pointing at 1, correct? Yes, this is the initial scenario. So now what would happen is we will check is 1 plus 16 is equal to 25. Is it equal? Nope, it is less than 25. So because it's less than, we are going to increment A to the next step. So now A becomes 9 plus 16. Is it equal to 25? Yes, 16 plus 9 is 25. So we would say that yes, it is equal. Break here and return that the loop contains a Pythagorean triplet. Assuming that in this case, right, instead of 9 it was 8, just what would happen? So assume that instead of a 9 here, we swap it out with an 8. Assume that we had instead of 8 we had 2, right? We put 2 square is 4. We had a 4 here because we are storing squares. If we had a 4 here, this iteration would have also failed. A would have then tried to go to B. Since A equal to B, this full cycle would end here and we would again pick up the next block. Like next iteration, it would be 1, 9. Sorry, instead of 9, we have gone with 4, right? So 1, 4, 16, 25, 36 and 81. 36, 81. So of which we would have exhausted 81 is exhausted, 36 is exhausted, 25 is exhausted. So we have A, B and C, only 3 positions are remaining. So in one iteration we'll check is 1 plus 4, is it equal to 16? It's not, it's less than. We'll try to increment A, right? Increment A, then we get to know that A, position of A equal to B, right? So when this occurs, when a equal to b, we'll say break the loop. But then since the length of this array is already 3, you cannot have less than that, so you can break, you can exit out saying false, there is no items, because if it contained a Pythagorean triplet, we would have written true in the above cases, right? When the list size is already 3, the position of C, we can always keep a counter. When position of C is less than 2, right? Since it should be 0, 1, 2, when position of C is less than 2, you can break off. So that could be our exit condition also. Return with false. So this would be how we could probably address this problem. Okay, with this, let's now try to get that in, trying to code that out. Right, let's see if that's possible. So first step is we copy the code. The code is here. Given an array, we copy the question, come back to the problem, save that, determine whether it contains a Pythagorean triplet, right? So first if triplet present, and we are going to say source numbers, right? Numbers return false. The worst case scenario, we are going to return false. Best case, inside we are going to return true if it contains a. Okay, step 1 in this whole procedure was, let's just ensure we have the steps ready. So okay, if you had to write the steps once again, right? One was calculate squares, right? First we calculated the squares, calculate squares. First we get the squares out, then sort it off so that it's in an order, right? Second step is we sort it. Third step is in a for loop, right? Keep have a at 0, initially start at a at 0, c at ending -1, we'll have an end index, end -1, ending position, and b at end -1, right? Initially we have this end -1, and then check within iterations of each. So if we were to do that, step 1 is source numbers is equal to I star I for I in source numbers. We can actually update the same array over here, that way we will not occupy more space, right? So we could do that, and then we can have, let's confirm in Python, right? Python, if we have an array, say a equal to 496, we have an array, did I miss something? Okay, 496, we are going to just do, right, we have the sort method, so we can directly call on it. No, or we can even call this sorted function. Yeah, a dot sort only we can do. So what we will do is same way, source numbers dot sort, right? So this would be our step 2, sort the squared numbers. We're doing this so that we can always have a counter. So initial a is 0, right? b is equal to no, c equal to, we'll have that as abc, right? Start, mid, end. Actually you can call it start, mid, end, but rather c is equal to len source numbers, right? And then b is equal to c minus 1. This would be our initial indexes, and we have to keep going on until while a greater than b. I mean, well, a is greater than or less than, no, because we would be going from left to right, right? Let's confirm that. So initially a was 0, 1, 2, 3. When it became equal to b or greater than b, it would fail. So it should always be as long as a is less than b, right? Please continue with this. Okay. Exit. And we can close the lower terminal. And c greater than 2, right? Because we don't want c to also decrement. It should be always, no, it can come to 2, no, 0, 1, 2. We can have it c greater than 1, 0, 1, so it should be 2. Okay, fine. If this is the case, this would be our settings. With this in the scenario, now what we need to do is we need to check if source, right, source numbers of a, right, plus source numbers of b equal to source numbers of c. If this occurs, right, if this occurs, that means that we have hit this spot where it's a Pythagorean triplet. So we can just say return true, right? We can actually print it from the print. Pythagorean triplet. Inside which we'll have three numbers, source numbers a, b, and c, right? Correct. We have a, we can have b, and we can have c. Perfect. Right, this is the condition. Since we are returning from here, no need for incrementing anything. If this value, right, actually we can store it here. Current sum is equal to this, right? If current sum is equal to the third value, then it is there. If instead of again summing it up, if current sum is less than the source numbers, right, that means that our sum can improve. Like we can have we can move ahead in the, right, we can move, like if in our example when we were at 1 plus 9, when we got to know 1 plus 36 is less than 81, when we got to know, we moved a from this position to the next one, right? So that way we can now move a. So in that case, what we are going to do is a plus equal to 1, right? We're just going to increment 1. B remains the same, C also remains the same, right? Else if, I think we can have an elif here only, right? Elif, right, current sum is greater, assuming that we have already got a very large number that is larger than the sum. Then what we would do is we would say that, hey, source numbers of C, right, then we'll say that b should be incremented. Like we would move b, like when did we occur in that cases, when when we had 16 plus 25 was greater than 41, right? We had that scenario at one point, right? So yeah, this is the one, this scenario when we were here 16 plus 25 is greater than 36, so then we incremented b so that it moves to the next step in the left hand side direction. Else, so what would this else be? This else would be the case where would we have an else case? It's either equal or it's less or it's greater than, right? It's equal, it's lesser than. Okay, we don't need an else case. Actually, even this whole elif block we can remove and keep it only as else, but for now I'll just pass for now that, so that I can understand what is happening over here. B gets incremented or A gets incremented. instead of that we can have else. Comment this out so that we are aware what is happening. So instead of having an extra condition and stuff. Okay, so now this case would occur, we would increment. So the first iteration we would check whether this would match with this. Let's print that out, right? That way it's print. A, B, C. I want to see the values of A, B, C in this iteration, right? But in which case am I decrementing C, right? Okay, 1 second. I will start from, this would start with A is equal to 0, right? A would start from 0, B would be, as soon as this completes, right? A would start from 0, 1, 2, 3, and then we get to know that it is not working. C is not getting incremented. Like this would work if in the first pass itself we got it, right? If we had a, if the last, if C was the only like the Pythagorean triplet, it would work. We are not handling the case where C is not the Pythagorean triplet. How do we do that? We need to handle that also, right? So which means that we should actually not start with A equal to 0 len C. Like in each iteration, how we came from each one of these iterations, right? We always started with A is equal to 0, B is C minus 1, and C is the last element. We need to always iterate. So which means that this should itself should be in another loop, right? For example, we can have another while loop, I guess, but it's determined, like we know the number of steps for, yeah, we can have it in another for loop for this is like how many positions C can be, right? Like because let's say we have an array, so it will be like 1, 9, 16, 25, 36, 81. C initially was 81, right? This was C's value, and in this whole while loop currently now we didn't get the solution. Now C doesn't get incremented, right? Next step is C needs to go to the next position that is available to it. It cannot always be source nums, it should be some other value. So that value, so that in the next iteration over here it picks up C is now 36, we need to decrement, go left. So for I in range, right, len source numbers, I want to go negative, right? I need to step back, right? I need to step back. I need to go in reverse, so I need to say that step is second parameter, right? Yes, this one is till where you have to go. Like it can go up till 1, because if it goes below 1 then it doesn't make sense, which means I don't need this and C greater than 1, because C will always be up to 1 only over here. So does this satisfy the condition? If we have this, right, so what would be C would be the, rather we can take C from here only, right? This makes sense. So first iteration C would be starting from length. What is the length? 0, 1, 2, 3, 4, 5. 6 numbers are there. So we would start from 6, is it? 6 would fail. So you should start from 5, which means I should, because length source numbers is 6, 6 minus 1 is 5. So position 5, starting with position 5, right? And you're going up to 1, correct? Okay, so start with 5, A is 0, B is 4, That makes sense. It would be pointing here, right? When C is this, B would be this in the first iteration. Makes sense, right? It would be here, and A would be here. A would be position 0, right? Right. Next, we go through this entire while loop. We get to know that, hey, I did not return. Then we would decrement C, so we will come to 36, position 4. B would become 3, right? That makes sense. And A would start initially from here only, right? We would go, yeah, I think this should ideally work for that logic also. Let's now try. Now we built the logic which would have the problem. Let's now see if we can test it out. If name equal to source num equal to 2, 3, 6, 8, 11, 23, 56, 5, 11, 13. Okay, and now we have that. Let's see. Let set is triplet present? Actually, it doesn't make sense to call triplet present. Is triplet present, right? Or contains triplet. Contain triplets is a better word. Yeah, makes sense. Contains triplet. We're going to pass in source now and then print it back. Let's check whether it works. Right, now let's run the program. Let's run Python problem 110. List index is out of range. Okay, first we started at 9, we kept going on. At some point, right, when we started from 0, 1, then we decremented 7 to 6, 4, 6, 7. Iteration. Let's verify what is going wrong. Iteration. Okay, so what we have is, if a plus b, right, if a plus b is equal to sum, return true. That makes sense. Else, if a plus b less than, if it is less than c, we are incrementing a, right? We are going a by one step. That makes sense. Correct. Then we are doing else increment k. Is b, sorry, decrement. Wait a second, b should not be incremented, right? In this case, b is getting incremented, whereas here we were, what is the logic? If a greater than b, somewhere we had a logic, right? Yeah, if a greater than b, then increment a. Let's rewrite that logic here. Let's have the logic box over here where we have following three tiles. So we have when a plus b greater than c, increment a. Correct? So that it is it increment a? No, it is greater, no? So it's decrement b. Sorry, yeah. It should be decrement b. That's why I think we're making the mistake. We know we're decrementing b, right? So the case of 16 plus 25 is greater than 36. We should decrement b in the sense that we should move it one position to the left. So we should decrement b, and a plus b is less than c, right? Then in that case we should increment a. When a plus b is equal to c, return true. So I'm doing plus a, right? I'm doing plus a, not doing minus b. Sorry, it should be negative b. Let's try it again. Okay, it's returning false. At least there is no exception. Let's verify whether there is a triplet. Let's add one more triplet over here. 3. We know that 3, 4, 5 is always a triplet, right? So we have 3, we have 4, we have 5. So that should return true. Are we getting true? Let's verify. Yes, we are fine. Yes, 3 square, 4 square, 25. Perfect. So that makes sense, right? That kind of makes sense. Let's try with one more Pythagorean triplet. In that case, 5 we have. I think in this list we already have 5. Yes, we have 5. 13. I think we can add 12, no? 12 would also make it a Pythagorean triplet. 144 plus 25 is equal to 169, right? So we can add a 12 somewhere in the between. It's going to get sorted anyway. And we can remove this and make it an 8. Save it. Test. 25 plus 144, 169. Okay, and it's returning true. I think with this should be resolved. Okay, I think this should work. Thank you.